In 2003, this exact spot was nothing but open sea, empty water lapping against an empty stretch of Singapore's coastline. And if you had stood here back then and told an engineer that within a decade, 3 leaning towers would rise from that same water carrying a 2-hectare ship on their shoulders, 200 meters in the sky, they would have told you it was physically impossible. And yet today, that impossible ship is real. It holds an entire swimming pool, hundreds of trees, and a waterfall that appears to pour straight off the edge of the building into open air. And somehow, every drop of that water stays exactly where engineers calculated it would stay. So the real question is not whether this building looks insane. It obviously does. The real question is, how do you get a 57-story tower to lean on purpose, hold that lean for 200 meters, and still be strong enough to carry a ship-shaped structure heavier than anything that has ever balanced on top of a skyscraper before? And the answer to that question starts not in the sky, but 25 meters underground in mud. Before a single tower could rise, engineers had to solve a problem almost nobody watching this building today ever thinks about, because underneath this reclaimed patch of Singapore sits 25 meters of soft marine clay, the kind of ground that swallows weight instead of supporting it, ground so unstable that an ordinary foundation would slowly sink the entire structure sideways over decades. So instead of fighting that clay, engineers decided to go straight through it, driving the building's foundation down until it reached solid bearing layers far below, and that decision alone would define the next several years of construction. The concept itself came from architect Moshe Safdie, who reportedly sketched the entire silhouette of 3 leaning towers connected by a floating deck in a single afternoon. A sketch so audacious that turning it into a buildable structure required an entirely new category of engineering. Because nothing like this had a blueprint to copy from, every single calculation had to be built from first principles. To prove those piles could actually carry the load engineers were asking of them, workers loaded 9,000 tons of dead weight onto a single test pile, an amount of force most bridges never experience. And even after that pile held, engineers did not simply trust the result. They checked every single outcome against their models anyway, because on a project this ambitious, confidence without verification is how disasters happen. Keeping that excavation dry while piles were driven required 300 pumps running without pause, fighting constantly against groundwater trying to reclaim the hole. A detail that sounds minor until you realize that if those pumps had ever failed for long enough, the entire foundation work could have been compromised, and that detail would matter again, dramatically, years later. Because these towers lean, no 2 columns on the leaning face of any tower share the same angle, meaning literally every single vertical element on that facade required its own unique engineering detail. There was no repeatable standard component anywhere on that leaning surface. Every piece was effectively custom, calculated individually, poured individually, and verified individually before the next floor could begin. Workers walking those upper floors during construction have described physically feeling the tilt beneath their boots, an unnerving sensation on a building site. But that lean was never an accident or flaw to correct. It was the entire design intention from day one, engineered precisely, tolerated deliberately, embraced completely. The concrete used throughout these towers was engineered to be nearly 3 times stronger than what a typical building requires, and every single batch delivered to the site was independently tested before it was allowed to be poured, because a leaning tower under this much stress cannot afford even one weak batch buried permanently inside its structure. As these 3 separately leaning towers approached their final height, engineers faced an entirely new challenge because eventually those towers needed to physically connect, and one of the most complex points in the entire structure became a single reinforcement node containing 900 individual steel bars converging at one location. A node that took 6 full weeks of dedicated planning before a single bar could be tied in place. 4 tower cranes operated at 180 meters above the ground throughout this phase of construction. And while most people assume the hardest part of using a crane that high is putting it up, the genuinely difficult engineering challenge nobody thinks about is safely bringing each crane back down once its job is finished, a slow, meticulous, carefully sequenced process in itself. Because these 3 towers lean independently and move independently in the wind, engineers installed specialized bearing systems between them, allowing for 300 millimeters of relative movement, a deliberate flexibility built into the connection points specifically so the towers could shift slightly without damaging each other or the structure connecting them above. During construction, monitoring data revealed that Tower 1 had moved 4 millimeters more than models predicted at level 45, a discrepancy that sounds insignificant until you understand it. Forced engineers to recheck load assumptions across the entire structure because on a project where every measurement compounds across 200 meters, even a 4 millimeter deviation demands explanation. The building's curved glass and metal exterior required 2,400 individual panels, and on the leaning face of Tower 1 specifically, not a single one of those panels shares the exact same shape as another. Each one individually calculated to match the precise curvature and lean at its exact position on the facade. At the peak of construction, 3 distinct construction operations were happening simultaneously on top of each other on every tower. Structural work, facade installation, and interior fit-out all progressing at once on different levels, requiring roughly 3,000 workers dedicated purely to the building's exterior shell alone. As the sheer mass of the towers grew, the entire structure sank 32 millimeters into the ground beneath it during construction. A movement that sounds alarming until you learn engineers had precisely predicted that exact settlement in advance and designed the entire foundation system specifically to accommodate it. When all 3 towers finally reached their designed final heights, the accuracy achieved after 200 meters of independent leaning construction was almost unbelievable. Tower 1 finished 3 millimeters above target, Tower 3 finished 6 millimeters below target, a total spread of just 9 millimeters across 3 separate buildings against an allowed tolerance of 15 millimeters, an extraordinary result for a structure this complex and this tall. The building's expansive convention center required 10 enormous curved concrete petal-shaped roof structures, and remarkably, every single piece of formwork used to shape that concrete was built once, used exactly one time, and then discarded, because no 2 petal sections repeated the same geometry anywhere across the entire roof. Fire safety systems inside the building reached a scale most visitors never consider, with one single room alone containing 1,667 individual sprinkler heads, and every single one of them was pressure tested, individually before the room was ever considered complete. Deep inside the casino, vault walls were constructed to a thickness comparable to specifications used in nuclear power facilities, a detail that sounds like marketing exaggeration, until you realize it is the literal engineering specification the design team actually worked to. Above the casino floor, the ceiling space available for every single mechanical, electrical, and structural system supporting the room measured just 800 millimeters, meaning every pipe, cable, duct, and support beam feeding that entire massive gaming floor had to be engineered to fit inside a gap barely deep enough to slide your forearm through. Surrounding the building's basement level, engineers constructed a single, continuous, underground retaining wall using 480 individual concrete panels, each one 25 meters deep, forming what engineers internally referred to as one giant watertight bathtub, sealing the entire basement against the surrounding water table. Inside that basement complex sits a 2,000-seat theater built specifically for large-scale touring, productions, and remarkably, the entire structure floats on 240 isolated spring mounts, an engineering solution specifically designed so that no vibration or sound from the surrounding casino resort ever reaches the performance space above or below it. The building's dramatically curved exterior facade required every single panel to be positioned using laser-guided surveying equipment, and across the entire installation, not one single panel needed to be removed and replaced due to error, a remarkable outcome considering the scale and complexity involved, because Singapore's daytime heat made certain concrete pours structurally risky. Engineers made the deliberate decision to pour roughly 40% of the building's total concrete volume overnight, when ambient temperatures dropped low enough to avoid uncontrolled curing stress inside the mix. Some of the building's mechanical shafts required surveying accuracy of 0.5 millimeter, maintained across 200 meters of vertical height, a tolerance so precise that each individual shaft required 2 full weeks of dedicated laser alignment work. And with 15 separate shafts required per tower, that single task alone consumed months of specialized labor. Rather than build each hotel bathroom individually on site, the project team pre-built 2,561 complete bathroom pods inside a factory, then craned each finished pod directly into position inside the tower, sealing the exterior facade closed behind it once it was set in place. High above all of that underground and mid-level construction, the load path supporting the building's now famous infinity pool actually begins as low as level 42, meaning the forces from that iconic rooftop pool are engineered to transfer downward through dozens of floors before ever reaching the ground. The specific concrete mix used throughout much of the structure was formulated with a chemical property engineers refer to as self-healing, meaning hairline cracks that naturally develop over time can actually seal themselves through ongoing chemical reactions within the material, a detail that sounds like marketing language, but is genuine, verifiable material science. For 4 full years, a dedicated team of 40 workers did nothing but continuously keep freshly poured concrete moist across the site, a job that sounds almost mundane compared to crane operators and welders. Yet, it is precisely why so much of this building's concrete achieved its exceptional long-term strength. Structural steel plates used throughout critical sections of the building measured 80 millimeters thick, each one requiring 16 individual weld passes to fully join, and every single weld across the entire project was verified using ultrasonic testing equipment before being approved. As construction crews continued working directly against the building's core walls, they were quite literally touching a structure actively rising beneath their hands, a wall that had not stopped moving upward continuously for 18 straight months. Along the building's dramatically curved facade, engineers installed 240 individual mullions, each one precisely positioned using a surveying instrument called a theodolite. And because of the building's continuously changing curvature, not a single mullion angle repeated anywhere across the entire facade. Coordinating 4 separate tower cranes operating simultaneously 180 meters above the ground, with booms constantly overlapping in shared airspace, required one single dedicated coordinator managing 4 separate radio channels continuously, achieving an outcome of 0 collisions across the entire construction period, an extraordinary safety achievement given the complexity involved. At the very peak of the towers, structural concrete measured 600 millimeters thick, reinforced at 3 times the density used elsewhere in the building, specifically engineered to support the enormous concentrated load about to arrive from above. Because the waterproofing membrane installed beneath the future rooftop garden could never realistically be repaired once soil and landscaping were placed permanently on top of it, engineers made the decision to test literally every single centimeter of that waterproof membrane before allowing construction to proceed any further. At peak production, the project consumed 3,200 cubic meters of concrete every single week, with every individual batch logged and every raw ingredient tracked and controlled, an industrial scale of quality control rarely seen even on major infrastructure projects. In certain sections of the building, engineers discovered that specific floor slabs actually experienced upward lifting forces trying to pull them away from their supports, an unusual structural condition requiring 4 dedicated steel rods specifically installed to hold those slabs firmly down against that unexpected uplift. In an especially clever piece of engineering, certain sections of formwork were deliberately built 12 millimeters higher than the intended final measurement, specifically because engineers knew the concrete would naturally deflect downward slightly once it cured and bore its full structural load, meaning the finished slab would settle into perfectly level position exactly as designed. Across the entire project, roughly 10,000 construction workers labored for 4 continuous years. And remarkably, the project maintained a safety record better than the broader Singapore construction industry average throughout that entire period, a genuinely significant achievement on a project of this scale and complexity. Before construction crews ever encountered many of these problems physically on site, engineers used detailed computer modeling to identify 3,400 separate design clashes in advance, resolving conflicts between structural, mechanical, and architectural systems digitally before they became expensive real-world mistakes, ultimately saving the project an estimated $120 million in avoided rework. Beneath the entire complex, engineers designed 4 basement levels containing 2,500 parking spaces using a post-tension slab system specifically chosen because it eliminated the need for deep supporting beams, maximizing available headroom throughout the entire underground structure. The building's architect reportedly sketched his original vision for this structure on simple tracing, paper back in 2004, and just 5 years later he found himself physically standing on top of one of his own leaning towers, waiting for the massive connecting deck above to finally arrive. That connecting deck, the ship-shaped structure that would eventually define this building's silhouette worldwide, measured 340 meters long and was actually manufactured in an entirely different country before being shipped across the sea in massive sections, arriving piece by piece to be lifted directly into position high above the towers. Individual steel sections weighing 90 tons each were lifted directly from barges floating in the harbor below, straight, up to a height of 200 meters, with crews working continuously around the clock for 4 straight months to complete the lift sequence, and bolting just 2 of those massive sections together at 200 meters above the ground required 6 hours of extraordinarily precise coordinated work. That very first connecting section set an enormous engineering challenge in motion, because every additional section lifted into place afterward caused measurable deflection in the sections already installed, forcing engineers to predict every single millimeter of that cumulative shift in advance before construction could even begin. At the most extreme point of construction, roughly 9,000 tons of structure hung suspended in open air, cantilevered an astonishing 67 meters beyond its nearest point of physical support, an engineering feat that many outside observers reportedly assumed simply could not be done safely at this scale. Securing Tower 1's connection to the deck alone required 1,400 individual bolts, every single one tightened to an exact specified torque, and then visibly marker painted afterward as permanent proof of correct installation. Pumping concrete 220 meters straight upward to reach the deck level pushed available pumping equipment to the absolute mechanical limit of what modern concrete pumps are capable of achieving. The rooftop pool's overflow weir, the edge responsible for creating that famous, seemingly endless waterfall effect, had to remain level to within 3 millimeters across its entire 150-meter length, because even a tiny deviation would have made the waterfall visibly uneven to anyone looking up from the street below. When the pool was finally filled with water for the very first time, the entire deck structure dropped exactly 17.4 millimeters under the added weight, remarkably close to the 18-millimeter deflection engineers had predicted months earlier, and the resulting waterfall effect was reported to be perfectly even across its full width. 250 full-size trees were installed at 200 meters above ground level along the deck. In species selection, specifically prioritized trees with naturally shallow root systems capable of thriving within the limited soil depth available on a rooftop this high. Along certain sections of the rooftop deck, the only barrier separating visitors from 67 meters of completely open air below is a single 19-millimeter thick pane of structural glass, engineered without any additional support posts interrupting the view. Constructing that particular glass viewing section alone required roughly 6 months of dedicated specialized work before it was ready for the pool above it to be filled. Keeping the rooftop waterfall continuously flowing requires 145 kilowatts of power, running without interruption. Every single second the feature is operating, an intentional and substantial ongoing energy cost built directly into the building's operational plan. High above the ground, structural welding along the deck was performed using full penetration welds, with steel preheated to 150 degrees, and much of the actual welding work conducted overnight to maintain more stable working conditions. A specialized protective coating measuring 225 microns thick was applied across the deck's structural steel, engineered specifically so the entire Sky Park structure would not require repainting until the year 2034. Roughly 150 meters of stainless steel trim was calibrated to 0.5 millimeter accuracy per section before being permanently embedded into the surrounding concrete. At every single point where the deck connects to one of the 3 leaning towers below, engineers built in a deliberate structural gap, allowing 150 millimeters of movement with a sliding cover. Plate specifically designed to shift back and forth every single time the wind pushes against the structure. The open-jointed stone tiles covering much of the rooftop deck were installed over a hidden drainage void beneath them, and every single tile across the entire deck was individually slip-tested while wet, before being approved for public use. Once the very last structural bolt on the entire deck was finally torqued into its final position, the completed structure measured just 8 millimeters from its original design coordinate, an extraordinary result after 5 full years of continuous, extraordinarily complex construction work. Looking up from the waterfront, 200 meters below at night, visitors can now see the rooftop pool subtly glowing above them, just barely visible against the night sky. Before the deck's concrete was even poured, engineers cast 840 separate anchor points directly into the structure, permanent attachment points that every single maintenance worker still clips their safety harness into today whenever working at height on the rooftop. A single pipe measuring 800 millimeters wide connects this entire building directly into Singapore's district-wide cooling system, delivering chilled water efficiently throughout the massive complex. The building's total installed electrical capacity reaches 120 megawatts, distributed through 600 kilometers of internal cabling, enough combined power capacity to supply roughly 80,000 ordinary homes, all consumed by this one single building. During the final push toward opening day, construction crews completed 12 entire hotel rooms every single day for 7 consecutive months, and remarkably, not a single one of the resort's finished rooms was designed to face inward toward the building's own internal courtyard. The casino floor itself houses 2,500 individual slot machines, each one connected through its own dedicated fiber optic line and individually calibrated before opening. Deep inside the shopping mall beneath the casino, engineers built actual functioning canals complete with real water, and the gondolas that glide along them are entirely genuine, fully operational boats, rather than any kind of decorative illusion. Across the building's exterior, 40,000 individually addressable LED lights were installed, overnight work to complete. Filling the rooftop Sky Park pool and achieving water clarity sufficient to satisfy Singapore's National Environment Agency approval standards took 11 full days of careful, closely monitored work. Throughout the Umbitas building's fire protection systems, 80,000 individual smoke detectors were installed, and remarkably, during the building's very first year of operation, 47 genuine fires were recorded inside the complex, yet not a single guest was ever injured in any of those incidents. Because Tower 1's dramatic lean made it physically incompatible with any standard commercially available facade cleaning system, engineers had to design and build an entirely custom cleaning system completely from scratch, specifically engineered around that tower's unique angle. The casino's primary vault door alone weighs 22 tons, and its precision locking pins had to be cooled in liquid nitrogen simply to achieve the exact fit required, with the entire mechanism tested 200 separate times before the vault was ever certified for actual opening day use. Every single passenger elevator installed throughout the resort underwent 500 complete test cycles before receiving final safety certification, and the dedicated Sky Park Express elevator was engineered to travel all the way from ground level to the 55th floor in just 36 seconds. In the final stretch before opening, inspectors identified 68,000 individual defects requiring correction across the entire massive complex, and construction teams worked at a pace of roughly 700. Fixes completed every single day. Yet even with that relentless pace, approximately 10,000 items still remained officially open. On the actual morning, the resort welcomed its very first guests. Every single major air handling unit throughout the building was craned into position and installed before the surrounding facade panels were permanently sealed shut, specifically because engineers designed the system so that if any unit ever required replacement in the future, that same section of facade could be reopened rather than demolished. The building's climate control system operates across 5 separate pressure zones per tower, supported by 15 dedicated pump sets in total, all of which have been running continuously, essentially without interruption, since the resort's official opening day on April 27, 2010. An automated waste collection system quietly removes roughly 8 tons of rubbish from the complex every single day, pulling it through 3.2 kilometers of underground pipe at speeds reaching 70 kilometers per hour, completely invisible to the millions of guests walking above it. Security coverage across the casino floor includes 480 individual cameras, positioned so that every single gaming table on the floor is continuously monitored from 2 completely separate angles, simultaneously with camera on. Placement planned entirely through digital modeling long before the casino ever opened. The resort's food service operation spans 36 separate kitchens, and remarkably, every single one was specifically designed so it can be fully deep cleaned without ever requiring the restaurant operating directly above it to close. On its very first day of operation, the resort reportedly generated 6 million Singapore dollars in revenue within the first 24 hours alone, an early signal that this $8 billion gamble was going to pay off exactly as its engineers and financial backers had hoped. The very first guest to step into the rooftop infinity pool did so at precisely 7:03 in the morning on opening day, and by every account, the famous waterfall performed exactly as engineered, remaining perfectly even across the entire 150-meter span for everyone watching from below. Within its very first full year of operation, the resort generated 2.7 billion Singapore dollars in revenue, roughly 15% above initial financial projections, proving conclusively that the engineers, architects, and financial planners behind this extraordinary project had gotten their fundamental calculations right. By 2019, the single building had reportedly appeared in over 1 billion photographs shared across the internet, an almost unimaginable scale of visibility for a single structure, yet one that was deliberately designed from the very beginning to become exactly that kind of unmistakable, instantly recognizable landmark. A 4th tower is now reportedly planned for the site, carrying an estimated additional price tag of $4.5 billion, meaning the very same building that fundamentally changed Singapore's skyline once is now preparing to reshape it again. Today, more than 40 universities around the world reportedly use this project as a formal teaching case study, an extraordinary outcome for a structure that began its life purely as a casino hotel and somehow became a genuine engineering textbook example instead. Since opening in 2010, that rooftop waterfall has run every single night without exception, with only one notable interruption during the global pandemic, meaning what many visitors assume is simply decorative lighting, and water effects is, in engineering terms, permanent operating. Infrastructure running continuously for over a decade. 1,770 piles driven through unstable clay, 3 independently leaning towers rising in perfect coordinated unison, one 340-meter connecting deck lifted section by section 200 meters above the sea, and an $8 billion final. Price tag, and once you understand everything that actually happened beneath, inside, and around this building, you finally understand what that impossible-looking ship sitting on top of 3 crooked skyscrapers truly represents: a structure built entirely on reclaimed seafloor, driven through 25 meters of soft marine clay, resting on 1,770 individually engineered piles, standing 200 meters above the water, and somehow, against every early assumption about what could physically be built, It worked exactly as planned, and it still stands today as proof that the impossible is really just an engineering problem waiting patiently for someone determined enough to solve it. So if structures like this fascinate you the way they fascinate us, subscribe now, because there are even more astonishing megaprojects waiting to be broken down next.